If you want to build a house, you hire a contractor, sign a few papers, and you just kind of hope for the best.
Right. Yeah, lots of hoping involved there.
Exactly. But if you want to build a multi-billion-euro industrial mega project in the middle of a desert, or, I don't know, off a remote coastline, you definitely do not rely on hope. You use what is basically a weaponized legal framework.
Oh, absolutely. Hope does not get a refinery built.
No, it does not. So for today's deep dive, the document we have sitting in front of us is titled EA-Tier Red Book Scope of Work Mechanical Works. Specifically, this is document SOW-ME001 Revision 0, dated May 16th, 2026.
Quite a mouthful.
Yeah, to the untrained eye, it sounds like a 300-page cure for insomnia. But for you listening right now, this is actually the ultimate translation tool. It's the invisible architecture that takes a massive multi-million euro imagination and forces it into physical reality.
And crucially, it does it without thousands of engineers just suing each other into oblivion.
Right. Okay, let's unpack this. Because to understand how the physical steel actually gets built, we really have to understand the framework governing this entire document. It's based on the 2017 edition of the FIDIC Red Book. And the premise is, well, it sounds deceptively straightforward. The employer provides the design, and the contractor executes the construction.
Yeah, but the friction lies entirely in that execution part. I mean, before anyone even picks up a welding torch, this text establishes how reality itself will be interpreted.
Reality itself, that sounds pretty intense.
It has to be. On a mega project, you're dealing with overlapping authorities, literal mountains of schematics, and, conflicting national and international laws. The project needs a referee. And this document capitalizes that referee as the engineer.
The engineer, with a capital E.
Yes, exactly. And this isn't just a guy in a hard hat with a clipboard. It's a legally empowered entity appointed by the employer to administer the contract. They are, essentially, the Supreme Court of the construction site.
And to give the Supreme Court a way to make rulings, the contract creates this incredibly rigid order of precedence.
Yeah.
It's basically a hierarchy of truth, right?
Precisely. It removes the ambiguity of human debate.
So running through this hierarchy, number 1 is the FIDIC Red Book conditions themselves. 2, the particular conditions. 3, the employer's requirements. Coming in 4th is the specific scope of work we're looking at today.
Right, the SOW.
Yeah. 5th is the unit rate schedules, which they call Schedule ME. 6th is the standards and codes. And then dead last, in 7th place, is the contractor's drawings.
Yeah, so if the contractor submits a drawing that shows a pipe routed one way, right, but the employer's requirements demand it routed another way, there's zero negotiation.
Because the employer's requirements sit at Tier 3 and the drawings are way down at Tier 7.
Exactly. Tier 3 wins automatically. It saves weeks of arguing.
Okay, but I'm looking at Tier 6, the standards and codes, and it is a literal alphabet soup. I mean, it lists ASME VIII, API 610 and 618, API 650 and 620, ATEX, LO layer. I get we aren't talking about residential plumbing here, but why does this document defer to all these different international acronyms instead of just following the laws of whatever country they're building the plant in? I mean, think of the hierarchy of laws like a constitution versus local bylaws.
What's fascinating here is how the document anticipates the clash between local sovereignty and international engineering physics.
Engineering physics?
Yeah, because the reality is the host country will always have its own HSE, health, safety, and environmental legislation. You cannot just ignore local laws.
Sure, obviously.
But local laws often lack the extreme specificity required for this kind of infrastructure. Take the ATEX directive, for example, which governs equipment used in explosive atmospheres. If you're building a gas facility, a single static spark from a poorly grounded motor could literally level the entire site. Or take ASME VIII, which governs high-pressure vessels, making sure the metal won't rupture under immense stress. These international codes are practically written in blood. They're the global gold standard for preventing catastrophic failure.
I mean, that makes sense, but what happens when the local country's law says one thing and, say, the American Petroleum Institute, or ATEX, says something totally contradictory?
Well, that is exactly where the supreme power of the engineer comes into play. The contract explicitly states that when local national laws clash with international codes, the engineer determines which standard governs the situation.
Wow, so they really do have the final say.
They do. They have the authority to decide the safest, most compliant path forward, and their ruling is final.
Okay, so the engineer holds the ultimate power to prevent legal chaos. But let's actually look at what they are policing. When you open the work breakdown structure in this document, specifically the MEM01-200 series, you really get a sense of the sheer physical reality of this project. It lists 25 distinct equipment categories.
Right. It's the complete mechanical anatomy of a massive industrial organism.
We're talking compressors, mixers, HVAC, waste treating equipment, and the scale of it is just terrifying. Every single one of those 25 categories is broken down into 11 weight bands.
Yeah, from the very small to the unimaginably large.
Exactly. The smallest band is equipment weighing less than 1 ton, but the largest band is for massive structures exceeding 1,000 tons. Try to wrap your head around moving a 1,000-ton piece of equipment. That's the equivalent of dropping a mid-sized office building into a highly congested construction site in one single piece.
The physics of a lift that massive require a staggering amount of temporary infrastructure. I mean, you can't just drive a standard crane up to it and hook it on.
I would assume not.
The mechanical contractor has to analyze soil settlement, they have to account for wind shear, and often they're synchronizing multiple crawler cranes working in tandem.
Just to move one piece of equipment.
Just for one piece. And they are responsible for the unloading, the handling, the positioning, the alignment, down to millimeters of tolerance, and the final bolting of that equipment.
Here's where it gets really interesting for me. I'm looking at item 015 here, and it's called Pig Launcher and Receiving Units. Please tell me this isn't agricultural, because otherwise I have absolutely no idea what farm animals are doing in a massive industrial pipeline contract.
No livestock involved, thankfully. A pig is just an old industry term for a pipeline inspection gauge.
Oh, pipeline inspection gauge, PIG, I get it.
Right. So once a massive pipeline is operational, you can't just shut the whole thing down to check if the inside is corroding or to clean out sludge. Instead, they use this highly specialized device, the pig, which is packed with sensors or cleaning scrapers.
So how does it get in the pipe?
Well, the launcher is a pressurized vessel that forces this device into the live flowing pipeline without letting any of the volatile product escape. And then the receiver is a massive catch basket at the other end.
That sounds incredibly dangerous.
It is. Installing them requires high-pressure closure doors and interlock systems, so an operator doesn't accidentally open a vessel that has thousands of pounds of pressure sitting right behind it.
That's wild. And the scope mentions other highly specific things too, like scrubbers, venturi and packed column scrubbers, and flare tips with ignition systems and wind deflectors.
Yep, it's incredibly detailed.
But then, and this is what surprised me, it dedicates an entire section to express exclusions. It explicitly bans the mechanical contractor from doing certain jobs.
Yes, the boundaries again.
Right. Like they don't do civil work, so no foundations or piling. They don't do process piping beyond what they call the battery limits. They don't do electrical power supply beyond the first local isolator. And they are strictly forbidden from doing DCS or PLC programming. Now, I get the concrete part, but what is DCS or PLC?
So DCS stands for Distributed Control System, and PLC is a programmable logic controller. You can think of them as the digital brain and the nervous system of the plant.
Okay.
The mechanical contractor is just there to build the muscle and the skeleton, the heavy steel, the rotating equipment. They are explicitly walled off from writing the code that actually tells those muscles when to move.
And what about the isolator thing?
An isolator is the literal physical switch that cuts the electrical power. By stating the mechanical team stops at the isolator, the contract creates perfect battery limits.
If we connect this to the bigger picture, a battery limit is basically just a hard physical boundary line, right?
Exactly. If we connect this to the bigger picture, it is an engineering property line. Think about it. If the civil contractor builds a concrete foundation and the mechanical contractor bolts a 1,000-ton compressor to it, what happens if the whole assembly starts vibrating dangerously?
Oh, I see. Is it an unbalanced compressor, or did the concrete team pour a weak foundation?
Precisely. By defining the battery limits, by saying the mechanical contractor's liability begins exactly at the anchor bolts and not 1 millimeter below, the text eliminates the gray areas where contractors would normally try to hide their mistakes or blame someone else.
That reliance on strictly defined boundaries makes total sense when you realize how fast a single physical mistake can ruin a project of this scale. Which I guess brings us to the testing and documentation phase.
The quality assurance phase, yeah.
Because you've just bolted down a volatile, high-pressure system. You can't just flip a switch and see if it explodes. So looking at Session 5, the contractor deliverables, there are 15 distinct requirements.
And they are strictly enforced.
Right. Like you have Method statements for major lifts due 21 days before the activity. Inspection and test plans, or ITPs, due 14 days before. And as-built drawings due 30 days after completion.
It is a quality management system mapped directly to ISO 9001.2015. Those inspection and test plans, the ITPs, they are really the heartbeat of the site's safety. They break every physical activity down into specific checkpoints. You have hold points, witness points, and review points.
Wait, what does a hold point actually mean in practice?
A hold point, designated with an H, means the contractor literally must drop their tools and stop working. They cannot proceed until the engineer physically inspects the work and signs a piece of paper granting permission.
But what about witness and review points? Because, I mean, if every single step is a hold point, nothing would ever get built. The engineer would just be running around all day.
Exactly. So a witness point, a W, means the contractor must formally invite the engineer to watch a specific test, say a hydro test of a pipe. But if the engineer is busy and doesn't show up at the scheduled time, the contractor is allowed to proceed. They don't have to halt the entire project.
Okay, that makes more sense.
And review point, an R, is even less restrictive. It just means the contractor performs the work and sends the resulting paperwork, like the torque logs from a flange bolting, for the engineer to review after the fact.
Okay, speaking of paperwork, I really have to push back on the medium of this paperwork because it jumped right off the page at me. This document is dated May 16th, 2026, yet it heavily mandates hard copies.
Ah, yes.
For almost all 15 deliverables, they require 1 electronic copy, sure, but they also demand 1 to 3 hard copies, 3 physical bound hard copies of an operation and maintenance manual in 2026. Why not just drop a link to a secure cloud drive? It feels incredibly archaic, like a bureaucratic, paper-heavy nightmare.
To an outsider sitting in an office, it absolutely looks like a bureaucratic nightmare. But you have to remember the environment these plants are built in.
The desert, the coastlines.
Right. These mega projects are often located in extreme deserts with blinding dust or offshore platforms or hazardous zones where bringing an uncertified electronic tablet could literally trigger an explosion due to a microspark.
Oh, wow. I didn't even think about the spark risk.
Yeah, a cloud server can lose connectivity. An iPad can overheat in the sun and just die. In those extreme environments, a physical piece of paper, stamped in ink, and signed by the engineer is an unhackable, undeletable failsafe. It's tangible proof that cannot be altered retroactively by a server glitch or, a malicious contractor trying to cover their tracks.
Okay, so it's the ultimate physical backup system.
Yeah.
And speaking of covering tracks, the document has 0 tolerance for hidden mistakes. It outlines NCRs, non-conformance reports.
Yes, the NCRs are critical.
If a defect is spotted, the contractor must submit an NCR to the engineer within exactly 24 hours. I mean, managing thousands of workers and thousands of tons of steel, 24 hours is an incredibly tight window.
It is, but the physics of construction demand that tight window because mistakes compound. If a team misaligns a base plate by just half an inch on Monday and they don't report it, the next team comes in on Tuesday and welds the structural steel to that misaligned plate.
And then the next team builds on that.
Exactly. By Friday, you have an unfixable disaster that requires tearing down a whole week of work. So, forcing a strict 24-hour reporting window ensures the engineer can assess the defect and decide how to remediate it before the literal and metaphorical concrete sets.
The layers of verification are just endless. The text outlines FATs, factory acceptance tests, meaning the equipment is tested before it even leaves the manufacturer's warehouse.
Then SATs, site acceptance tests.
Then pre-commissioning. And I love the specific details here, like visual checks, torque verification, and my personal favorite, bump tests for motors.
The bump test is so critical. A massive industrial motor has immense kinetic energy. If the electrical team wired the phases backward, the motor will spin in the wrong direction.
And I'm guessing that's bad.
Oh, it's catastrophic. Running a massive pump or a compressor backward at full speed will tear the internal machinery to shreds in seconds. So they apply power for just a fraction of a second, a bump, just to visually confirm the rotational direction is correct before committing fully.
Brilliant. Just a quick jolt to see which way it spins. And for overhead lifting equipment, they invoke those LO layer regulations we mentioned earlier, demanding a proof load test to 125% of the safe working load.
Right. You have to prove the crane can lift 25% more than it will ever be legally allowed to carry.
And only after all of this is done, the hold points, the bump tests, the 125% lifts, do you finally reach what the contract calls mechanical completion, meaning the system is officially ready for the volatile process fluids.
But arriving at mechanical completion brings up the most contentious part of any project.
Mm.
The physical labor is done, yes, but the flow of capital is an entirely different, equally complex mechanism.
Show me the money. Section 9 governs measurement and payment. Everything is transacted in euros, which makes sense, but they don't just, hand over a giant briefcase of cash.
Definitely not.
Payment is based on composite unit rates, mapped back to that Schedule ME we saw in the order of precedence. And these unit rates are supposed to be all-inclusive, right? Like materials, labor, man-hours, overhead. Subclause 12.1 says the engineer physically measures the completed work on site, verifies it against the approved material takeoffs, and then authorizes an interim payment certificate in a monthly statement.
That assumed the project went exactly according to the original drawings. But at this scale, the blueprint never survives contact with reality. The plan always changes.
Which is handled under subclause 13.1, variations. The contractor cannot start varied work without a written instruction from the engineer. And if the new work is so strange or custom that it doesn't fit the unit rates in Schedule ME, it gets bumped to subclause 13.6, which is called day work.
Right, day work.
So what does this all mean? Let me try an analogy here. Imagine you are at a high-end restaurant ordering off an a la carte menu. That menu is Schedule ME. You know exactly what a compressor costs to install, just like you know what a steak costs.
Okay, I'm following.
But suddenly, you want an off-menu dish, a variation. The chef, who is our engineer in this case, has to formally write down the request. Because the dish isn't on the menu, there's no set price. So instead, you agree to pay for the raw ingredients plus the chef's hourly wage to make it. That is day work.
That's actually a great way to put it.
And just like the NCRs, the contractor has to submit day work records within 24 hours because paying for time and materials heavily incentivizes working slowly, right?
Exactly. This raises an important question, though. The restaurant menu analogy works perfectly for the immediate transaction, but it ignores the long-term reality of industrial construction.
How so?
Well, what happens when that expensive meal makes you sick a week later? When you leave a restaurant, the transaction is over. But here, the financial relationship doesn't end when the contractor leaves the site. Section 10 covers the defects notification period, or DNP.
Ah, the DNP, which is typically 12 months from the date the taking over certificate is issued.
Right. And during those 12 months, the contractor must return to the site and fix any defects at their own cost. This is the ultimate lever of accountability. It forces the contractor to have financial skin in the game long after their heavy cranes have been packed up and sent home.
So they can't just build it and run.
No, they can't. If they cut corners during the installation of that 1,000-ton compressor, they won't just get a bad review on Yelp. They will be legally required to pay out of pocket to fly specialized crews back to a remote desert to fix it. It perfectly aligns their short-term financial incentives with the long-term reliability of the facility.
That is incredibly smart. So let's pull all of this together. We started with a document, SOWME001, that sounded like endless dry bureaucracy. But what we've actually uncovered is an incredibly sophisticated system for managing human fallibility.
Managing human nature, really.
Yeah. We walked through the order of precedence, where the engineer wields supreme authority over clashing international codes to prevent catastrophic explosions. We navigated the sheer physical scale of 1,000-ton installations, exploring how battery limits prevent contractors from blaming each other when things go wrong.
And we looked closely at the intense paranoia of the quality assurance phase. The 24-hour reporting windows to stop mistakes from compounding, the physical hard copies serving as unhackable fail-safes, and the bump tests and 125% proof loads required to finally reach mechanical completion.
It's just a mountain of verification.
It is. And for the listener, while you may never need to install a pipeline pig launcher or argue over ATEX directives, the underlying architecture here is universally applicable. Understanding how to establish rigid boundaries, manage overlapping authorities, and align long-term financial incentives, well, that can be applied to any massive collaborative endeavor you face in your own life.
It really is a masterclass in organized collaboration. But, I want to leave you with a final thought to chew on. We've been looking at a highly rigid, profoundly paper-heavy system. It relies on physical signatures, tangible bound manuals, and an immense amount of human trust placed in a single entity known as the engineer.
Very true.
But as we move deeper into the 2020s, the technology surrounding us is shifting radically. So how long until these massive FIDIC contracts are entirely replaced by blockchain-based smart contracts?
Oh, that's an interesting thought.
Right. Imagine a near future where mechanical completion isn't verified by a guy with a clipboard, but by an integrated digital sensor on the compressor itself, which instantaneously triggers an automatic crypto payment to the contractor's wallet.
No paperwork, no engineer.
Exactly. It would remove the human referee entirely, fundamentally changing that translation of imagination into physical reality that we started with. It's definitely something to think about. Until next time, thanks for joining us on this deep dive.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching. Please subscribe and see you next time.